Good morning, everyone, respected teachers, seniors, and my dear friends. My name is Arati Lohar from second semester representing Bose Group. The topic of our presentation is Aurora, the beauty of nature. Today, we are going to focus on certain subtopics like what actually Aurora is, how is this beautiful phenomenon caused, why are the light shows in the sky colorful, and furthermore. First of all, let us look at the contents. We have what is Aurora, its history, how does Aurora actually form, and the key points like solar wind, magnetic field of the Earth, magnetosphere, aurora oval, why is it colorful, when and where we can see aurora, followed up by the non-traditional auroras and the references. Moving
Sorry,
on.
Arati, I'm just going to interrupt. Sorry, but can you speak a little closer to the mic? Your volume is a little low.
Okay, sir.
Okay, thank you.
Moving on. What is aurora? Aurora is a Latin word for sunrise. It is a colorful light show in the sky caused by the sun. It is basically an electrostatic phenomenon when particles from the sun interact with gases in our atmosphere, causing beautiful displays of light in the sky. They are usually observed in the night sky, particularly in the polar regions. Most auroras occur in a band known as the auroral zone. Let us talk about the history of aurora. In 4th century BC, Aristotle made one of the first accounts of aurora borealis described as the glowing clouds. In medieval times, the occurrence of aurora was seen as harbingers of war or famine. Similarly, in late 16th century, William Gilbert conducted experiments and came to conclusion that Earth itself is a giant magnet with north and south pole. Around 20th century, Norwegian scientist Christian Birkeland placed a spherical magnet inside the vacuum chamber and shot an electron beam at it. He found that the beam was guided by a magnetic field to hit near the pole, in which he concluded his experiment by saying that magnetic field played an important role in auroral occurrence. Aurora, how? How is this beautiful phenomenon caused? The activity that creates auroras begins on the sun. Sun emits electrically charged particles from its surface, called as a solar wind. Most of these charged particles gets deflected by Earth's magnetic field, and some of the ions become briefly trapped, which move towards the polar regions. In polar regions, they collide with gases like atoms of oxygen and nitrogen in Earth's atmosphere. This energy released during these collisions causes a colorful, glowing halo around the poles, which is called an aurora. Now, the variation in color of aurora depends on the gas with which it undergoes collision. Since solar wind and Earth's magnetic field is an important part of the aurora, we have our next topic, solar wind. The Earth is constantly immersed in the solar wind, which is a stream of charged particles, mostly electrons and protons, emitted by the sun in all directions. The faster the solar wind is moving, the likelier you are to see an intense northern lights display. The normal speed of the solar wind is roughly 300 km per second, but the fast moving solar wind is usually between 500 to 800 km per second. When the wind speed reaches this threshold value, geomagnetic storms are very likely to occur. Auroras can then become very bright, colorful, and dynamic, which means that on increasing the intensity of the solar wind, auroras are more frequent and brighter during the intense phase of the solar cycle. Here now is my friend Sudhanshu Pradhan to talk about the further topics.
Thank you, Arati. And moving on with the presentation. As we all know that the core of the Earth is made up of iron and nickel alloy with some other elements. Due to the rotation of the alloy, a magnetic field is generated which surrounds the Earth. As the charged particles from the solar wind, that is, electrons and protons, encounters Earth's magnetic field, they travel along the field lines. The magnetic field which is facing towards the sun is compressed by the solar wind, so they are closer to the Earth. But on the opposite side, the field stretches away from the planet like a tail. As the field stretches, they break like an overstretched rubber band. While some pieces head off into space away from the Earth, some parts snap back towards the Earth. These pieces then accelerate the particles that is captured into the Earth's atmosphere. Next slide, please. In astronomy and planetary science, a magnetosphere is a region of space surrounding an astronomical object in which charged particles are affected by that object's magnetic field. It is created by a star or a planet with an active interior dynamo. An example would be an Earth with iron-nickel core. The magnetic field of the Earth, which was shown in the previous slide, is a magnetosphere. It is the main reason for the formation of aurora as it accelerates the particle and transfers it to a higher energy level. Next slide, please. The electrically charged particles which stream down the magnetic field of the Earth reach the neutral atmosphere in a rough circle called aurora oval. It is the footprint in the atmosphere of the boundary between the highly stretched field lines of the polar cap and the more normal field lines at the lower altitude. The diameter of the aurora oval is roughly around 3,000 kilometers. As you can see, here are two figures depicting the aurora oval on the northern and the southern hemisphere. Next slide, please. The color of aurora vary depending upon the altitude and the kind of atoms involved. On the upper layers of atmosphere, that is 150 miles above the Earth, red color of aurora is observed. The most common color, green, is observed between 100 miles to 150 miles above the Earth. Purple is seen from 60 miles above the Earth to 100 miles, while the lower layers of atmosphere, that is, lower than 60 miles above the Earth, blue color is observed. Now I would like my senior Priyam Right to continue the presentation.
Thank you, Sudhanshu. Uh, Now, why this aurora is colorful? It's because the charged particles, that is, electrons and protons in the solar winds, encounter the Earth's magnetic field and they travel along the field lines. Now, on the sunward side of the Earth, the magnetic field is compressed by the solar wind to be closer to the Earth. However, on the night side of the planet, the field stretches away from the planet like a tail. Eventually, this magnetic loop stretches so much that they break like an overstretched rubber band, and a piece of it heads off into space away from the Earth, while the other part snaps back towards Earth. The, the piece that is snapping back towards Earth accelerates the particles it captured into the Earth's upper atmosphere. When these particles hit molecules in Earth's atmosphere, they trigger light displays depending on the altitude and the energy of the collision. As you know, most of the molecules in Earth's atmosphere are either nitrogen or oxygen, so they are mostly frequently hit molecules. Typically, nitrogen will produce red, violet, or blue color, while oxygen usually produces green or yellow. Red Red color is generally emitted above 240 km, while green at 100 to 240 km, while purple and violet above 100 km, and blue at 80 to 100 km. Next slide, please. Now, let me tell you when and where this aurora is formed. So, in North Pole, which is it's referred as northern lights or the aurora borealis. Its best time to see them is from January to March, while in South Pole, which is referred as southern lights or the aurora australis, is the best time to see them is from June to August. Next slide, please. Now, 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 auroras is observed in other planets like Jupiter, Saturn, Uranus, but not on Mars, Venus, or Mercury. Now, any planet with a magnetic field and an atmosphere should likely have auroras. And auroras can also be seen in Jupiter's moon, which is Ganymede, which is the largest moon in our solar system, and it's the only moon with its own magnetic field. So it's the only moon where auroras is observed. Next slide, please. Now, I like to conclude our presentation by reading out a quotation by Eugen Rosenstock, which says, "The aurora borealis may now have connected with magnetic disturbances and storms in a very distinct manner, and if the variation of the atmosphere cause both, it will also tie both together by a common hub." Next slide, please. And these are some of our reference sites. And thank you.
Thank you.
Thank you, Priyam.
Okay, well done, all three. Satyan, you have any questions?
I do not have any question. Initially, I could not listen properly. I'll ask a general question to the presenters that in the earlier discussion, we have studied the optical fiber phenomenon and all other things. Now, the usage of optical fiber is within our hands. It is an industrial development, you can say, using the natural phenomenon of total internal reflection. Now, this aurora, do we have anything in our hands to observe it, to change its pattern, to do something on it, or it is totally a celestial phenomenon? Answer. Is it a celestial phenomenon or human being has something to do on it?
So it is a celestial phenomenon.
Who is answering? Sudhanshu?
Yes, sir.
Okay, good. It is a celestial phenomenon. We have nothing to do with this thing. Right? Okay. Now, in Mercury, as you have pointed out, that the aurora is not observed. Is there any answer with you? Does it mean that there is no magnetic field?
So could you please repeat?
As you told that in the planet Mercury, there is no aurora. Aurora is not observed in Mercury.
Yes, sir.
But in Jupiter and other planets, Uranus, you have mentioned. But does it mean
Yes,
that
sir.
there is no magnetic field in the Mercury?
So it has, but Mercury has. Mercury does not have atmosphere, sir.
Oh, I see.
It
Okay
has
then.
so
Good.
it had atmosphere, but like it's almost like it does not have no atmosphere, right? Like so.
Okay, good. Anyway, I appreciate your efforts because at this age, we are not in a position to present such type of things when we are in your stage, BSc level, right? So I appreciate your exposure as well as way of speaking, courage, and the technology you have adopted. I mean, the technical know-how, right? So I appreciate the group for your nice presentation. You go on doing this thing, improve gradually. Thank you. There is no question from my side further.
Thank
Next.
you.
Next, proceed.
Okay, I'll just make some comments on the group presentation first. First of all, I quite like the presentation, and I think Neha was presenting the slides, right? Neha, could you present the slides again?
Sir,
Sir,
it is Ms.
Arti.
Arati.
Oh, sorry,
Arti.
sorry. Arti was presenting the slides. Can you present the slides again? I'm so sorry. Right. First of all three of you, I really, really liked the pacing of your speech and the cadence and the pronunciation. Very good, very clear. At no point was I confused. At no point did you rush anything. That is really good. All three of you. This is the kind of pacing that you'd want to take when you are trying to do a presentation. And this is something that even I have difficulties with. Another thing I liked is, can you forward like a few slides? I'll just go forward a little bit more. Yeah, so for example, what I like is, yeah, this is a good example. This is a decent background. This is a very nice background. It is non-intrusive. The Aurora effect is right on top, so it doesn't block the words. I can clearly read the words compared to the background. The graphics are clear, but not too intrusive. There is a lot of written material here, but that's fine. You guys are talking about it. So this is a good slide presentation as well. This is a good choice of background where everything works out well together. So again, this is another thing that I would like to highlight. This is also quite nice. And one small criticism I'm going to make. Go to the slide that says non-terrestrial auroras. Right. So in this case, I think Priyam was talking on this. This is the part where he says that any planet with an atmosphere and a magnetic field would have an aurora, but there is no magnetic field written in your written material. You actually need to put that in. The magnetic field part, from memory, if I remember correctly, it is very important for a planet to have some sort of magnetosphere to generate any sort of aurora. Okay, so that needs to be in there. I actually don't have any questions. So that's about it. It's a very good presentation and I quite liked it. So well done, all three of you. It's very clear that you put in the effort required. So it is well done.
Thank you, sir.
Okay. I don't have
Thank you,
questions.
sir.
So I'm done.
Any other question from other side?
Any questions from students? Okay. So let me go ahead with the presentation. Everything looks perfect. The way you have put it and the way you have presented in a very crisp manner. Okay, so let me just ask you one question. So you have said that the charged particles coming out from the sun interacts with the magnetosphere or the atmosphere of the earth along with the magnetic field and produces this color or spectrum of colors, right? So what are those gas molecules which are mainly responsible for producing this color in the atmosphere?
So it is basically oxygen and nitrogen.
Sorry?
Basically oxygen and nitrogen emissions.
Okay, why other gases are not do not have so much of contribution?
So
Because our atmosphere
first of all,
consists of other gases also.
so the concentration is actually very less, first of all.
Fantastic. And they are lighter as well. Okay, so as compared to other gases, they are actually above the strata of oxygen and nitrogen. So even if they strike it, so they will emit blue or purple colors, which are vaguely visible to the human eyes. So most of the interactions that are happening is with the oxygen and the nitrogen molecules. Okay, thank you.
Thank you, sir.
Any other question?
Okay, hello everyone. Arati, Sudhanshu, Priyam. It was a very
Hello,
nice
sir.
presentation, and I really am happy to see that you all really went through this, did a good research before putting the things on the PowerPoint. Okay, so you're talking about magnetic field, right? So our Earth has a magnetic field, correct?
Yes,
So
sir.
any idea what is the value of that magnetic field? In I mean, what is the order in Tesla or Gauss? Or is it a very feeble magnetic field or a very strong magnetic field?
Very feeble.
Okay, good. Okay, now I would ask Arati to take me to the slide where it shows that northern and southern hemisphere. Yeah, exactly. Yes, this one. So very simple question. I'm planning in the coming years to see this on my own. So I'll just book the tickets. So where should I go in the North Pole? Which country should I land to see Borealis? What do you think?
Norway, sir. Norway.
Norway, okay. And in the Southern Pole?
So in Southern Pole,
Australia.
yes, sir.
Okay. Okay, thank you. I'll plan accordingly. Okay, okay, that's all from my side.
Actually,
It
I
was
do have a
a
question. Does Australia actually see the southern lights? Aren't they too high for it? I know you can see it from Antarctica. You can see it from Antarctica.
Mohit sir is relying on them. All the best, Mohit sir.
yeah.
He landed in
land
Australia and
safely.
like, where's the northern lights? It is seen in Antarctica. That is the researchers that keep seeing it, and they study it there as well. There's actually a geo base. I know Makmoto has a base that studies the southern lights.
Okay, then I'll just go to Norway. It's very cold on the other part. Okay, yeah, very well done. And one suggestion I can give you, everything is very beautifully collated. Like, see here you have written it is referred as blah blah. That thing also you may put in bold. Okay, can you do it, Arti, right now? Can you make those letters in bold as well? And let us see if that makes it. Control Z you do. Yeah, just check once. If you make everything bold. Yeah, now please show us. Now go to slideshow. Yeah. I think this is a bit more visible. What do you say? Is it? Okay. So this is also something, because when you would be doing it in physical mode, we would be projecting it on a projector, a huge screen. And if these are not bolded, what happens? It becomes very thin and it's sometimes a bit difficult to read. Okay. On a computer, it is fine. Right.
Okay,
That is the one observation that I would like to say. Okay. Anyways, very well done. Thank you, everyone. Okay, that's all from my side.
Okay, so the presentation was very good. And just one little question from my side. Is this Aurora borealis dangerous?
Yes, ma'am, if you come in contact with it.
Means what happens if you touch?
Most probably you'll get electrified.
Most probably. Okay, so do little bit research on this. Okay, so that was from my side, and really it was a very good presentation. The slides all were very good. Okay, so that's all.
Is there any other group?
No, sir, it's only two groups per day.
Very good, very good. Well within the time.
Yes, sir.
Very
This time we
precise.
weren't.
Very precise, distinct, and clarity of speech is also good. I encourage the effort taken by our colleagues to encourage the student to present such type of things. Very good. Overall, it is very good. I appreciate the effort taken by my colleagues as well as the effort given by my students. Carry on. And one last thing is that don't pay reduced or attenuated attention to your study materials so that you can secure good marks. This is the last sentence from my side. There should not be any dilution or attenuation in your attention. Okay. Vikram.
Yes, sir. I think Pajol sir has something to say.
Yes, I have one question. It just arose in context to Sujata ma'am's question. So, so ma'am said that, or is aurora harmful to the Earth's creatures? He said no. So you said no. But what if I say if there are, like, if the majority of the gases in the atmosphere are helium, okay, would that be harmful to us? Considering the phenomena of aurora borealis or australis. So majority of the gases in our atmosphere are oxygen and then nitrogen. So what if we had helium in its place? Would the aurora, would this phenomena be harmful to the human beings on Earth?
No, sir, I guess.
Sorry?
No, sir.
Okay. So the basic physics behind this is that, see, when a charged particle strikes an molecule, no? So it is basically exciting the electron in that atom. Okay, so that electron doesn't want to be in the excited state, and as a result, it after some time it goes to the original state. So as a result, it emits photon. So these photons are basically the, depending upon the energy of the photon, we see colors, no? So just like in, if it strikes oxygen and nitrogen, we see orange, yellow color. Okay, so had it been helium in this case, okay, the photons emitted as a result of relaxation of the electron from helium would emit blue light. Okay, so which is very close to the ultraviolet lights, and that way it would be harmful had there been a majority of helium gases. Okay, so ultraviolet lights are harmful to human skin, isn't it? So that is it. So this just came in my mind. Thank you everyone. Overall, it was a very good presentation. Both Bose and Saha group, you did very well.
But students, are you aware of the fact that what important things both Bose and Saha did? They are Indian. They were Indian scientists. What contribution was made by Bose and what contribution was made by Saha? Are you aware of this thing? The students of sixth semester, they might be knowing Fermi-Dirac statistics, Bose-Einstein statistics, and in that context, you must be knowing what Bose did. And what about Saha? Yeah, that out of curiosity you try to learn because it is out of the, purview of the topic. But we must know that they are our Indian scientists. We frequently name them, what contribution they have made. So this is a corollary of the, what should I say, discussion. Okay, that's okay. There is no other question from my side. Now you do the concluding part.